And so that means that we're going to take the derivative twice. So y prime would be the derivative of cotangent, which we should know off the top of our head. Isn't that secant cotangent or something like that?
Yeah, cotangent is negative secant squared.
No, it's not. Is it really?
Negative cosecant.
No, is it really? I don't remember off the top of my head. Luckily, I have you in my class and you remember. I thought it was like secant tangent or something.
The derivative of cotangent equals negative cosecant squared.
Was it at Rutgers?
It might have been. No, that doesn't sound familiar. All right, well, let me finish 31 though, okay? And then we'll talk about it. It's, oh, you said, I thought you said secant. Yeah, it's cosecant. Yeah, so for this one, I'm going to take negative cosecant of the stuff, which is 3x minus 1. Then I have to tack on the derivative of the stuff on the inside. Now, the way Mr. Adams learned this is that if I have y equals some function of u, that y prime would be f prime of u, and then you tack on the derivative of u, right? Or you'll, well, I'll talk more about that in the next section. But I need to multiply this by 3, because that's the derivative of the stuff on the inside. So I've got negative 3 cosecant of this stuff. Okay? So that, oh, and it's squared. This is squared. Sorry, I forgot to write that down. And so now y double prime is the derivative of that stuff. So the 3 stays out front. But remember, this is the same as cosecant of this stuff squared. Okay? So that means now I've got to toss this 2 to the front, and I have cosecant of the stuff on the inside. Now that's raised to the first power now as I take the derivative. But then I have to take the derivative of this stuff on the inside. So the first thing I need to take the derivative of is cosecant of 3x minus 1. Well, what's the derivative of cosecant of 3x minus 1? Well, isn't that, I think it's cosecant cotangent, and that's what I was getting a little bit ahead of myself. So we need to take the derivative of cosecant. Who remembers what that is, huh? Little Miss Smarty Pants, do you know now? Oh, what page is that on? I have it right in front of my face, but I want to find the page number to write down for the notes.
Negative cosecant times cotangent is the derivative of cosecant.
Negative cosecant
Of x.
of this stuff
Times cotangent of that stuff.
Okay, so that's the derivative of that, but now I've got to tack on the derivative of this stuff on the inside, which is what? 3. And so I'm just going to toss that to the front. Okay, so I've got negative 3 times 2 times negative 3, which is negative 18. But then I have this negative sign here, which will make that a positive 18. And then I have cosecant 3x minus 1 times cosecant 3x minus 1 times cotangent 3x minus 1. Now, what that means is I have cosecant times cosecant, which is cosecant squared. Now, I can do that because they have the same stuff on the inside. Only because they have the same angle. If this angle was different than this angle, then I couldn't square them up. Times cotangent of 3x minus 1. Now, you know, cosecant squared is really 1 over sine squared, and cotangent is cosine over sine. I could even, if I wanted to, I could make it like some funky It would be like, I think it would be like sine over, or no, it'd be cosine over sine cubed or something of all the stuff.
Well, that's not.
And so it doesn't simplify it, so we just leave it alone. You guys understand what I'm saying?
Yeah.
Okay, so we'll just leave it alone, and that's the answer in the back of the book. Remember, this is going to be the slope of the well, no, this would actually, well, this is something I haven't taught you yet, which is the concavity of the graph. But any questions?